Good morning, everybody. Welcome to this webinar of Secura. We have quite some attendees, so I will be starting in a few minutes. In the meantime, thank you very much for joining. We have a series of webinars, so in case it's something of your likings, go to our website and look for the webinar page, and you will see what else we have. In the meantime, let me introduce ourselves. Welcome to this webinar. You can see me as Edwin Spijkers and Raj van Venter, who is our team lead security certifications. In this webinar, we aim to elaborate on UNECE regulations for the automobile industry, which, if everything goes right, is scheduled to be published in 2021. We appreciate your attendance in such big numbers, especially considering the special circumstances we are at the moment. So we really appreciate that. Thank you for that. So first, please allow me to introduce Secura and myself, and then later when Raj van starts, he will introduce himself at the beginning of his presentation. So my name is Edwin Spijkers. I'm responsible for business development within Secura, and I'll be your moderator for today's webinar. The key presenter and content specialist is Raj van Venter, and he's also responsible for the automotive security compliance services within our company, Secura. Secura is a boutique cybersecurity company. We exist already since 2000. We're based in the Netherlands. We are an independent, specialized security center of expertise with offices in Eindhoven and in Amsterdam, the Netherlands. And our clients, both national as international, range from blue chip companies like banks, to government, military utilities, car companies, road authorities, among others. Quite a variety of companies we address. And in this fast pace of ever-changing digital environment, we help organizations like yourself to take control of your digital security, which is essential nowadays, and it's proven many times that digital security is essential for a good operation of your business. We have a holistic view where you can see in the screen where we have 5 different pillars that our company is based upon. So we have the training awareness, we provide the tools, we do the security audits, security testing, and above all, we also do assurance and certification. We're a big promoter of international standards, and that's also the reason why we do common criteria certification, among others. Like I said, we do this all from a people, process, and technology perspective. And in short, Secura is your independent and trusted security partner, taking care of all digital security, and we act as a one single point of contact, so you don't have to go to others to do all your cybersecurity needs. Let me come to a finish and hand over to Rajvan. In short, if you have any questions, please feel free to put them in the question mark. And besides that, you can always reach out to me. You have my email address, and I'll be glad to follow up on this. Then one other thing I have to say is that we record this session for future use and to send it out to people who yourself or to people who are not able to attend at this time, so be aware of that. Thank you very much, and Rajvan, the floor is yours.
Thank you very much, Ed, and good morning, everyone. Thank you very much for joining this webinar. My name is Raj van Venter. I am leading the security certification team within Secura, and within this team, we have quite a holistic view on cybersecurity and IoT security in general. And this includes, of course, the domain of automotive security compliance, certifications, and regulations. During the last couple of years, in fact, we have been closely involved with the work of UNECE in drafting new relevant cybersecurity and software update regulations, We have been also supporting them a bit in this process, as well as being involved in a large-scale pilot project, which took place last year in collaboration with several manufacturers of vehicles. Therefore, during this webinar, we're going to aim to provide you a bit of background into the topic of those new regulations that are currently being in the final draft phase, as well as share a bit of the lessons learned as a result of our conducted pilot projects. So in terms of the agenda, we will start with a brief overview of UNECE and especially an explanation of the way in which they monitor and issue vehicle-specific regulations. Then we will switch to the main focus of our presentation, which is, of course, the two regulations in scope, the Cybersecurity Regulation and the Software Updates Regulation. We'll very briefly go through them to provide you an understanding of what kind of requirements you can expect from those two draft regulations. Then we will go ahead in the second part of the presentation to explain a bit about our envisioned impact on vehicle manufacturers, mostly based on the lessons that we learned by conducting relevant pilot projects. And of course, we're going to end with a timeline in terms of the regulations and what could you expect from a next steps point of view in terms of the way in which those regulations will be future published and implemented. So to get started, a bit of background about UNECE. Well, UNECE stands for the United Nations Economic Commission for Europe, which might be a bit interesting because the word Europe appears in the actual name of the organization. However, as we're going to also see, UNECE is a very global organization which is spread across multiple continents. UNECE is focused on many aspects, and one of them is the fact that they are also actively publishing all sorts of regulations. There's one particular division within UNECE, which is called WP29, which is the World Forum for Harmonization of Vehicle Regulations. So as the name says, this division is mostly in charge of monitoring and publishing new regulations for vehicles, for cars, trucks, and so on. Within WP29, there are multiple working parties, and those are split per domains of expertise on the whole area of automotive. And some examples of those domains are in the slide, such as, for example, tires, noise, lighting systems, safety, seat belts, braking systems, and so on. There's one particular working party which is of interest to us for the purpose of this webinar, and that is the working party focused on autonomous and connected vehicles. And within that working party, there is a special task force on cybersecurity and over-the-air issues, which has been the main driving point behind publishing the first draft versions of those cybersecurity regulations. So that brings a bit of an overview about who are the people actively drafting those first versions of regulations. As mentioned, UNECE is a global organization. Currently, it includes 56 member states, and it's widely spread across multiple continents, including Europe, North America, so USA and Canada, but also a big part of Asia. So how does regulation work? Well, currently we have quite a bit of existing regulations issued by UNECE, which are covering multiple topics, mostly focused on the topics of safety and performance, functionality of vehicles. So examples of those regulations include regulations for brake system, airbags, lighting, tires, seat belts, and so on. And basically, when a new vehicle manufacturer or an OEM, we're going to use that name during the webinar, the OEM, whenever they have a new vehicle type, and a vehicle type is not necessarily a new model, it can be also a family of models which share the same characteristics with respect to one particular regulation. So whenever they have a new vehicle type, well, then they are interested in having it accepted for putting on the market on special markets in special countries. For that, they will need to get a so-called type approval in line with the relevant regulation, which is associated to a particular vehicle type. And in order to get a type approval, vehicle manufacturers will have to approach one local national approval authorities in the country in which they are targeting. And the national approval authority will be able to conduct all the assessment needed and conclude whether the new vehicle type is fully compliant with all the requirements of that respective regulation. The National Approval Authority can do the assessment by itself, as it actually happens with many of the regulations, but at the same time, they can also involve a specialized third party, which is called a technical service, which are pretty much labs having particular areas of expertise, such as, for example, cybersecurity. And in that case, the technical services are conducting either the whole or part of the actual assessment, so the compliance against requirements. They write a report, and then they share the conclusions with the approval authority, and then the approval authority can approve the type based on those conclusions. Of course, you might be wondering how it works in terms of mutual recognition, because as mentioned, UNECE has quite a few of countries under its scope. And of course, it would be quite time challenging and costly to be required to approve your type in all of those countries. Well, depending per regulation, so-called mutual recognition agreements do exist. Those are not all the same. So depending per regulation, more or less countries could mutually accept the type approvals issued by other countries. But whenever a new regulation is being introduced, that's always an important topic of discussion. How will other countries under UNECE recognize the evaluation results which are issued by one other country? In terms of the security, well, security hasn't been so much yet in the focus of UNECE, and in fact, in general, automotive regulations. And that kind of makes sense because, well, currently, if you take a look at what available automotive regulations do exist, those are mostly focused on items such as safety and performance. We have been having cars and vehicles for already many years, and safety and performance, reliability, robustness, and so on have always been very important topics. However, recently, and this is not only the case of automotive, but in the case of IoT in general, we see more and more threats and risks which are being developed. And even the more concerning part is that those threats are slowly developing from purely theoretical vulnerabilities to things that can be really exploited and performed in practice. Year after year, we see more and more examples of threats being published and performed in reality on a real car in real situations. So that is the concern that led to the need of creating dedicated regulations, for example, regarding cybersecurity. But what can go wrong? What could lead to those possible threats? Well, modern day vehicles, they are more and more connected. We have a lot of so-called smart features or interfaces, connectivity interfaces into those vehicles. And the main purpose of those interfaces is, of course, to create a more efficient, a more enjoyable experience for the users, for the drivers of those vehicles. Nowadays, it's actually quite normal to include in our vehicles infotainment systems, road navigation, vehicle-to-vehicle communication, smart software updates, features like keyless entry, and so on. And those are all smart features that, for example, we didn't have so much, let's say, 15 or 20 years ago. Vehicles are a very big part of IoT. Also, considering their number, every country has a huge number of vehicles on their roads. And this extends not only to personal cars, but also other types of vehicles, such as trucks or buses or connected trailers. So in terms of those smart features, well, they have been slowly introduced during the recent years. However, so far, as actually was the case in other domains of IoT, such as consumer, medical, industrial, and so on, the focus has been strongly on functionality. That was the main driver for introducing new features. For example, nowadays, let's just put ourselves into an hypothetical situation. You want to buy a new car, and you're analyzing a new series of models. Probably you would not consider buying a vehicle which doesn't have support, for example, for smart navigation. We all use maps to go to our meetings, to go to our different places, and so on. At the same time, you would expect a minimum of interfaces, for example, USB and Bluetooth. Not having those interfaces would be quite inconvenient in those modern times. How about voice control? We all want to be able to initiate phone calls or send commands to the vehicle. That's already something that is not futuristic. It already happens, and it's already considered as normal functionality into our cars. However, all those nice, modern, and very useful, in fact, features do come with a price. And of course, the purpose of this webinar is not that much to dive into the actual security aspects that could be exploited onto a vehicle, but still keeping it on a high level. What can go wrong? Well, in principle, all of those new interfaces and new features, modules, are pretty much connected all the way to the main vehicle network, communication network, so-called CAN network, through CAN buses. And the reason why they are connected directly to this network is pretty much in terms of robustness and speed. Well, every interface, every module, every feature that you use into your vehicle, speed is essential. You want to be able to use the feature as quick and as efficient as possible. And because of this issue, you connect it directly, in most of the cases, to the internal network of the vehicle. Of course, that's not always the case. You can still do some sort of separation, which will in fact improve the security. But sometimes speed is so essential that you have to connect it as direct as possible. And direct connectivity does indeed open wide doors into your vehicle, because then in terms of hacking, whenever you hack, for example, the USB or Bluetooth or Wi-Fi interface of a smart car, you don't only hack into Bluetooth, but for example, you hack into the whole network, and from that point, you can access much more interesting components, like for example, safety critical components, such as the braking system or airbags or vehicle power unit. So that's why those security threats do cascade. And maybe they start from something small, like for example, a smart and innocent feature or interface, but they could go all the way to having in scope very large threats for our vehicles. So how would cybersecurity and software updates regulations help in this? Well, currently, of course, it's more of a best practice approach because we have no final regulations in place. So definitely, most of the manufacturers are already considering those issues. Security is on the table for most of the manufacturers of vehicles. However, there is no harmonized view on what should be there, up to what extent, what is good enough, and so on. It's mostly based on best practices, on the experience of your security team, on the budget that you allocate on this, also on the time that you allocate on this, and all those kind of factors. Moreover, there is no standardized process of development. So most of the times, it's also based, the approach towards security is not always proactive, but also reactive. For example, if some incident has been reported for some other car manufacturer, then of course everyone will start paying attention and update, for example, the security features that led to that particular incident. Well, all those features led to clear needs to have standardized in-place regulations for both cybersecurity and software updates, which are really modern day issues. Currently, UNECE is working on publishing those two regulations, and they are in the final draft version because they have been already circulated and worked around for the last 1 or 2 years. Currently, the aim is for 2021 to have the first versions published in place, but we're going to come to that later during our timeline. And indeed, we're talking about two different regulations, one specifically for cybersecurity and one for software updates. Talking about the scope of those regulations, well, quite a lot of vehicle types are already in the scope. There's a big overlap between the two regulations, of course. So both of them, for example, deal with the vehicles for transport of passengers, vehicles for transport of goods, and in particular in the cybersecurity regulation, also connected trailers are in the scope of those regulations. So now let's dive a bit deeper into the cybersecurity regulation. Of course, the cybersecurity regulation itself contains many requirements. Unfortunately, we don't have time to go through all of those requirements individually. That's why a higher level view will be adopted in this webinar. So starting with an overview of the regulation, well, the most important part from my point of view that can be highlighted is the fact that the regulation targets two main categories. So we're talking about the so-called Cybersecurity Management System, or the CSMS, and the vehicle type requirements. So what does that mean? In terms of the Cybersecurity Management System, that deals with a collection of all the processes, so the theoretical processes, which are in place at the vehicle manufacturer, the OEM, in order to design, develop, manufacture, and post-produce a new vehicle type. And well, it can be the case that manufacturers have multiple sets of processes. For example, if we're talking about a manufacturer which is spread across multiple continents or multiple countries and producing vehicles at multiple plants, well, then it can be the case that they have slightly different processes depending on their geographical location. So in that case, they will have either one very big CSMS or multiple instances of CSMSs, which is also fine. But it has to start with an approved and fully assessed cybersecurity management system, which involves all the processes relevant for the development of a new vehicle. Once such a CSMS assessment has been concluded and fully certified, that ends with the issuing of a so-called certificate of compliance, which is valid for 3 years. And on top of that certificate of compliance, follow-up type approvals for vehicle types can be initiated. So what would be the difference between the CSMS assessment and the vehicle type assessment? Well, looking from a very high level, the CSMS will deal, of course, with all the processes. So at that point, we're talking theoretically, how do you design your vehicles throughout the whole life cycle? Now, in terms of the actual vehicle type, let's assume that you have a new vehicle type. And the main question is, have you used correctly and completely all the processes into from the CSMS in order to design, manufacture, and finally produce your new vehicle. So that's ultimately the main question about the vehicle type requirements. As said, there are multiple requirements into the CSMS part. We will not go through all of them, but we have clustered them into several main topics. And those main topics are security management, all those processes, again, related to risk, from identification to assessment and treatment, response to cyber attacks and vulnerabilities, and finally, of course, dependencies with the whole supply chain associated with the vehicle. So a couple of quick words about those categories. Well, in terms of management, of course, good management is key for having a good process. Management refers mostly to the fact that the processes are well documented, well versioned, kept up to date, but especially the fact that clear ownership is associated with those processes. Of course, if you have even good processes, but people are not fully aware of them, or not fully aware that they are the ones who should be following them and keeping track of those actions, well, then the result will probably not going to be very successful. Moreover, all those processes have to go all the way to the top management, which needs to have a direct involvement into the cybersecurity part. So top management should be fully aware of the fact that cybersecurity introduced into the vehicle should fully address all the requirements in order to demonstrate compliance with the regulation. In terms of risk assessment, of course, that's not only a single process, but definitely it's a collection of processes, because it's a long phase of a good design. It starts from identifying possible security risk to your vehicle, and then all the way to the analysis of those identified risks, rating them based on several factors, which sometimes depend per OEM, and also prioritize the identified risks based on their likelihood and based on their rating. And then ultimately, for all the risks that have been analyzed and rated, definition of relevant security controls, which can be used in order to either fully remove or sufficiently mitigate the defined risks. And finally, of course, the testing and validation that has been performed to confirm that the security controls work in an expected fashion. Reacting to new vulnerabilities and incidents is definitely a very critical aspect. For example, whenever we design a new vehicle type, and that type is being approved, well, that approval refers really to a particular moment in time. So basically, you can say that up to point X, you are sure that all the applicable risks or the applicable vulnerabilities are sufficiently addressed into the vehicle because we have implemented sufficient security controls. But how would that scale for the next half a year, or next year, or the next 5 years? Because of course we know that those vehicles, they have quite a long expected lifetime, especially if we're talking about industrial vehicles that will range over dozens of years. So a good process to keep track of new incidents and new vulnerabilities and new risk is really essential, because as we have said in the beginning of the presentation, this part of cybersecurity risk is just starting and will very likely get bigger and bigger year after year. We're going to have smarter vulnerabilities, higher impact risks, and so on. So how do you deal with those processes? How do you take it into account during your development, during your manufacturing, and during your post-producing phases? How do you sufficiently release all necessary patches? What is your process for example, recalling vehicles back into the workstation? All those things have to be very, very, very well documented and very well kept in place in order to ensure that the vehicle is protected not only at the moment when it leaves the door of the factory, but also as much as possible throughout its whole lifetime. Finally, from a cybersecurity point of view, a very important category of processes deals with the supply chain. Of course, it will be very easy if vehicles are produced only by a single OEM with all of its parts and there's no or very limited external interaction. However, in our modern world, that is pretty much never the case. All of those vehicles require hundreds of parts that come from external suppliers, and at the same time require services like, for example, cloud connectivity or all sorts of web mobile applications that come also from external suppliers. So the supply chain interaction is really a critical aspect. So basically, from a cybersecurity point of view, OEMs need to be fully aware of what requirements they draft for their supply chain partners in order to ensure that what they get back fully addresses all the security controls that they want to have implemented into the end product. And of course, once you get back components, or ICs, or whole ECUs, or software, how do you validate that what you get back does indeed cover what you asked for? So there has to be another process of validation of the received elements. Therefore, dealing with the supply chain becomes a major part of the cybersecurity regulation. So far, we talked mostly about processes. So once again, from a theoretical point of view, now the vehicle type assessment, well, goes a bit further in the sense that now we have an actual type, an actual product, and we want to explore on this type the fact that the processes have been fully and correctly applied. Well, in this case, we will take a look at more concrete evidence of what risk assessment has been performed, what specific risks have been identified, what specific controls have been put into place, what are the vehicle critical elements from a security point of view, how were the measures put into place in order to protect the dedicated vehicle environment, such as, for example, cloud connectivity or web services, and so on. And finally, an assessment also on what kind of testing has the manufacturer put into place in order to validate that the particular type and the security features into the type behave as expected. So that's more from a practical point of view. Now, quickly, same kind of approach we can take for the software updates regulation, starting from the overview of the regulation, which in fact is very similar from a design point of view to the way in which the cybersecurity regulation is being drafted. In a sense that, once again, we have the clear split between the processes part and the vehicle type requirements. So once again, we're going to be talking about the so-called software update management system, SUMS, and the vehicle type requirements. From the SUMS, the same story. We have many requirements. We're not going to go through them one by one, but we have tried to cluster them into several clear categories, and those categories would be having good processes for updating and maintaining software versions, validating compatibility, interdependencies, and impact of new software updates on previously available software and hardware, ensuring the safety and security of the updates before sending them to a vehicle, and finally, of course, informing the users of the success of the update and also of the details of the update. So very quickly, taking them one by one, keeping track of software versions, that's always something very interesting, because from our experience, it feels like almost all the OEMs, almost all the manufacturers have slightly different processes of keeping track of software versions. One interesting concept that is being proposed into the new software updates regulation is the so-called use of the RxWin, so the regulation X software identification number, which is a single number, a single software main version that clusters together all the other smaller bits of software versions that are deployed into a particular vehicle type. That could be, of course, a useful concept, because in that case, you don't have to keep track for each vehicle of all the individual software, and you don't have to output all those individual software, but then you have a single main version to group all of those software versions underneath. However, we see that currently there's quite a lot of discussion regarding the practicability and easiness of implementation of the RxWin. So it is to be still seen if the RxWin will be fully required into the end version of this regulation, or other alternative ways of keeping track of software versions into the vehicle will still be allowed. Currently, that's under discussion. Validating the software in terms of compatibility and impact, it's a very important point of view, of course. Whenever we design new software versions, OEMs have to keep in mind the compatibility of those new software versions, both in terms of the previously available software for the same component, but also in terms of the actual hardware. So does the new software fully match the previous hardware? Of course, also impact is very important, because if a new software update has an impact on a previously approved component, for example, the braking system, which is under the scope of a different regulation, then it means that particular requirements of that regulation or particular approval will have to be reassessed in order to check if the impact of the new software update still allows the component or the vehicle as a whole to meet all the applicable regulations. Safety and security of updates are, of course, key figures. In terms of security, remember that we have a dedicated cybersecurity regulation. So from that point of view, the vehicle itself is fully under the scope of the cybersecurity regulation. However, for the software updates, we are mostly dealing with the security of the update process. So how can we ensure that once the update is being sent from somewhere, for example, the backend, all the way to the vehicle, how can we make sure that the update is not being intercepted and, even worse, modified on the way? So the security in terms of confidentiality and integrity of this process comes under the scope of the software updates regulation. In terms of the safety, of course, that's a critical aspect, maybe even more in the sense in the case of the wireless over-the-air updates, because vehicles would need to make sure that the update is fully downloaded, fully installed, and fully ready before restarting normal operation, therefore ensuring that no safety hazard can be introduced by the actual update process. So that's something very important to take into account, and a clear process for ensuring the safety during the installation and during the receiving part of the update needs to be documented. Finally, of course, informing the users is essential. Users need to be in full awareness and full control of the updates that are being sent to their vehicles. Several minimum information requirements are in place, such as, for example, the type of the update, the brief contents of the update, also as well as a prompt to let the users know that the update has been successfully deployed and a vehicle is once again into a safe state for driving. In terms of the type assessment, we have kind of the same story as we had in the cybersecurity regulation. So we had a long discussion about the processes in place, but now from the type point of view, we would like to focus more on the actual applicability of those processes into an actual vehicle. So we want to see more concrete evidence of how, for example, the actual software versions are managed on a vehicle based on the software versions management processes, and how is the security against compromise protected on the vehicle type for the particular way of sending the software updates, how the safety of the updates, and especially the over-the-air wireless updates, is being ensured, and finally, the particular ways in which the users can get actual information on the contents and success rate and progress of their software updates. Now that we took some time to go very quickly over the contents of those regulations, let's take a bit of time to analyze possible impact on vehicle manufacturers. And I have to start with a big disclaimer. Well, basically, the way in which we provide this feedback is based on the lessons that we learned throughout our conducted pilot projects, which have been, of course, very interesting and very useful experiences. But what we mostly learned from those pilot projects is the fact that pretty much all the manufacturers are expected to be impacted in a different way. We rarely see the same kind of impact or the same kind of concerns in different manufacturers that were in the scope of our conducted pilot projects. And that's up to some extent normal, because the impact depends on several aspects, such as, for example, the awareness of the regulation requirements. So how well prepared are you to receive this new regulation? The size and complexity of the already available processes. If you have something small in terms of process, then probably it's going to be easier to retailor than if you have big processes that range across multiple continents or countries, involve multiple actors, and so on. Of course, the dependencies with the external suppliers will play an extremely important role, and the amount of those suppliers and the degree of those dependencies, as well, of course, ultimately, as the experience of the internal cybersecurity teams, which will finally be the ones responsible to make sure that all the applicable requirements are met. However, keeping that disclaimer in mind, we did have some, let's say, common topics of interest, which we collected as a result of our conducted pilot, and those are the ones that we can share in order to also advise other manufacturers that are interested by those upcoming regulations. Well, something that we quite often saw indeed is the fact that existing processes do have to be tailored up to some extent in order to meet new requirements, and that could be something time-consuming, also depending on the size of those processes, of course. The scoping of cybersecurity is very essential. Most of the times, it's not only about the vehicle, but it's also about the vehicle and several services or cloud connectivity and so on. And all of those elements would have to come into scope. Of course, we don't say that you have to assess the security of the whole cloud service, but the way in which the cloud service interacts through the interface to the vehicle, that will be into the scope, because it really is really tied to the actual product, to the actual vehicle. Keeping track of software versions that it's something that maybe is not of concern, but definitely there are differences here between manufacturers, which is actually quite expected, of course. And it will be very interesting to see how those processes of keeping track with versions would meet the compliance with the requirements of the new software update regulation. Especially from a cybersecurity point of view, something very interesting that we found out are the internal design dependencies. For example, manufacturers who are already ongoing with the design of a new model might discover that new requirements in terms of cybersecurity would require a slight redesign of their already available controllers or features. And that maybe is not so difficult from a design point of view, however, will introduce big dependencies, big impacts, also in terms of how other components rely on those impacted components. And that could lead all the way to such a dependency or such an impact that complete systems might have to be reconsidered, which also translates most importantly in time. So time would be the major element of concern here. Finally, of course, the relation with suppliers, third-party companies who provide other components or software. That's always interesting because it deals well with drafting correct requirements, correct security requirements for those suppliers. And finally, of course, making sure that what you receive back fully addresses your expressed needs. So what are the next steps and what should we expect next in terms of timeline? Well, as mentioned, currently those two regulations are in the final draft phase. There are constant meetings within the UNECE and within the actual task force in order to finalize those documents and approve them. The intent is to make them first available in 2021. So let's see how that will develop, but at least this is the current intention. And also discussions have been into place in order to include a possible two-step approach, which would therefore minimize the impact of some requirements of the regulation on particular manufacturers. So a two-step approach would mean that some of the requirements are implemented first, and then some of the requirements are implemented maybe several years afterwards in an updated version of the regulation. Together with the two regulations, we will have a couple of support documents in place, very likely, because such documents are currently in preparation. In fact, we as Secura, we are supporting in that process as well. And those documents will mostly be aimed at providing extra guidance in the way in which the requirements of the regulation will be met, and also aiming to provide a common evaluation methodology for all the technical services which will be involved in the actual assessment, both for cybersecurity and for software updates of those applicable requirements. So those so-called interpretation documents will very likely be published together with the final versions of the regulations. Therefore, definitely we have very interesting times ahead. I'm very happy that we have been involved already into those new upcoming regulations. As mentioned before, Secura has been involved last year in several large-scale pilot projects that allowed us to have a good hands-on experience with the way in which the auditing and assessment and compliance analysis has to be taken into account. At the same time, we still keep an active support in drafting, in finalizing the regulation documents, as well as drafting the associated methodology, such as the interpretation documents. And we are absolutely very happy to get into further contact with you regarding all possible questions about the regulations, about the possible impact, about how to interpret certain documents, or even, of course, doing some preliminary gap analysis to prepare further for the moment when those regulations will be published and enter into force. And of course, besides the actual regulatory process, the requirements and compliance and so on, you can always count on a company as Secura for conducting part of the testing, either on system level or the whole vehicle. So bottom line, we are very happy to help you further, and please feel free to get in contact with either me or Evan about it. So thank you very much for your interest. At this point, I would be very happy to try to answer the possible collected questions that came throughout the webinar.
Yeah, thank you, Rajman, for this very interesting presentation and the view of Secura on this UNECE part. We have quite some questions. Let me start with the first one and then I hand it over to you. The first one is, will we receive a copy of the presentation? What we will do is we will send every individual who has attended the webinar, and unfortunately there was a limit on the number of attendees, but everybody who signed up will get a link of this webinar, and we'll also get some more detailed information on the whole thing. So I hope that answers the question that was asked by Tor Mikkelbast. The second question, Rakshan, if it's yours, is North America part of UNECE regulations too? That was Florian Schulz.
Yes, thank you very much. Indeed, North America is part of the UNECE regulations.
Okay, and how is the link to SAE expert for ISO SAE 21434? Have you, or is it something that we have to find out?
Very good question. There is definitely a link. So the ISO 21434 standard has been also a parallel track that has been actively developed during the last years. The standard provides requirements for the development of a well-implemented cybersecurity management system. In fact, if we go through the requirements of the regulation, we can very often, right now I'm talking about the cybersecurity regulation, we can very often see a good link between cybersecurity regulation requirements and the requirements of the ISO 21434. Therefore, it's definitely advisable for OEMs, for car manufacturers to aim for compliance with ISO 21434, because that will for sure help very much into achieving compliance with the regulation, with the cybersecurity regulation requirements. In fact, finally, and I will end with this, I mentioned the fact that we are providing parallel interpretation documents to support with the regulation, and very often in those interpretation documents, indirectly, we provide pointers to particular requirements from ISO 21434 as means to demonstrate compliance with the requirement of the cybersecurity regulation in scope. So long story short, yes, being in touch and being in line with the requirements of the 21434 will help quite a lot with a good approach towards the cybersecurity regulation.
Okay, I hope that answers the question. Thank you very much, Rajan. I have another one. Hello, is it possible for the authorities to remove a type approval during the life cycle of a vehicle which has been type approved at the beginning of its serial life? I do not know if that's something we can answer.
So if I understand the question correctly, that so that deals to the fact that a vehicle type has been approved, let's say based on the new cybersecurity regulation, and then at some point later, due to circumstances, this approval is being removed. Well, it's something that currently is not fully into the scope of the regulation requirements. So the regulation, the requirements set up the initial requirements for compliance, and very likely the final version of the regulation will also contain, let's say, rules based on which type approval, provided type approvals can be also revoked, and the conditions under which those revocation actions can be implemented. So it's something that we cannot provide for sure at this point. However, it's something very relevant, and I am quite confident that it will be addressed in the final version of the regulations.
Okay, thank you. We have another question. You do not mention ISO 21434. I think we answered it already, yeah?
Yeah, it's been implicitly answered indeed. So well, the intention was to not mention it explicitly in the presentation. Of course, it's a very relevant standard, quite well known in the automotive industry. So as answered to the previous question, without saying that you have to have ISO 21434 compliance in order to demonstrate compliance with the cybersecurity regulation, because that's not the intention. However, of course, it's strongly advised to rely on that standard as a means to fulfill a large part of the regulation requirements.
Okay, thank you. Another question we had, how many years after end of production is mandatory to provide support in this regulation?
Very good question, and something that has been actively discussed in the plenary meetings that we have been attending. Up to the extent that I can say to this question, currently there's no harmonized conclusion. The matter of where does production end and where does post-production start and where does post-production end, that has been discussed many times, and currently there is no final conclusion on this topic that I am aware of. At the same time, as a similar answer to one of the questions that was before, those aspects will be documented in the final version of the regulation. So they are currently in the final discussion round. Everyone agrees that it's a very important topic, which is actually the reason why currently a final agreement was not being reached. But once those things will be agreed, then they will be introduced in the final version of the regulation, because it will become a very important game rule around this whole regulation.
Okay, then we go to the next question. We have quite a lot of questions. So let's see, we have another 5 minutes for questions. There's a question from, does software updates regulation defines also wired updates with diagnosis tool or OBD ports?
Thank you. That's an interesting and quite technical question. Well, the OBD port is definitely into the scope of the regulation as being quite classical port through which software updates information about the software updates can be extracted. Well, the intention is not to make it mandatory that only the OBD port would be the only option, but that could be also kept a bit flexible, such that other options are available as well. However, the OBD port will probably always be one of the most commonly used methods to obtain information about particular software versions that are available on the vehicle.
Okay, another one. How is the customer or user? How is it for the customer or user to verify the type approval of or latest software update in the vehicle? So, in regard to UNECE, how does the user or the customer know that the vehicle has the latest update in there?
Yeah, that's a bit tied to my answer to the previous question. So indeed, there has to be a way through which the vehicle is able to report the software versions that are found on a vehicle, because that's being required not only by the user but also by the local authorities, such as, for example, the police should have a means to determine the software version out of the vehicle if needed. So it's not defined how, because several options could be in place, and the aim of the regulation, as well as for other requirements, is to be as flexible as possible. However, it's something that has to be considered into place by vehicle manufacturers. This kind of functionality of outputting software versions needs to be one way or another satisfied by the vehicle.
Okay, we have one more quick question. It's does the current wording of the cybersecurity regulation, so you permit third parties to get secure access, direct access to the vehicle data?
Okay.
If you can't answer it, we can take it back and come back and then put it in our reply to everybody who attended. So,
well, I'm going to do my best. First of all, I will try to make sure that I understand the question. So I guess this refers not to third parties as in the sense of technical services who are assessing the vehicle, because in that case, of course, technical services will have to have access to the vehicle data and the design and documentation and all the elements in order to be able to provide the complete evaluation. However, I guess the aim of the question is mostly related to third parties who are not security labs, but other third parties who might be interested in this data. And in that case, I would say that currently there's no clear requirement on either accepting or banning that. It's up to a decision of the OEM to grant access to third parties to particular details of the vehicle design. In fact, that might be even needed in terms of the collaboration with the third party requires the third party to know certain aspects in order to provide a good and secure component or service back. So there's no concrete ban or approval on that, as long as the interaction with the supply chain third parties is done fully correct, in the sense that there are clear requirements for the supply chain manufacturers and clear validation process for everything that you get back, in the sense that all the security requirements have been covered. That would be fine for the purpose of the cybersecurity regulation.
Okay, well, we've come to an end. We have quite a lot of more questions, and as promised, I will make sure that all these questions are going to be addressed in an email that I'll send out to you. Thank you very much for attending on behalf of Secura. Really appreciate it. And if you need any updates, if you want to know anything about the whole UNECE thing and what role we could help you play and how we can make this whole regulation go smoothly for you, please reach out to you. And like I said, in the next week, you will get a link and an overview of questions that have been asked and answers. And looking forward to work with you guys. And thank you very much for attending.
Thank you very much, Edwin, for moderating this. It's been a very nice nice collaboration from my point of view. And once again, thank you very much, everyone, for joining, and looking forward to stay in touch with you in the future. Thank you.
Thank you.